Hi everybody, and welcome to this episode that is being recorded in a slightly atypical location. We're in the Munich JetBrains offices, and I'm sitting down together with Alexander Sysoev, who is in charge of kotlinx.rpc. We're going to be talking a whole lot about remote procedure calls.
Yes, thank you, Sebastian. I'm glad to be here. Yes, we can start, I guess.
Yeah,
Do you want me to do an intro myself a little bit?
I mean, sure. Let's start with that.
Oh yeah. Basically, JetBrains is my one and only company. I'm working here a little bit over than 3 years. I started as a student, and a little more than a year ago, we started to do the kotlinx.rpc project, the hackathon project, and now I'm basically everyone. The whole team is me in this project. I'm doing everything, documentation, code, pipelines, everything on me, and I'm pretty happy with this. I'm pretty happy to talk about this now.
All right, that's awesome. Let's take one step back, just to lay a little bit of groundwork. RPC. I know it's remote procedure calls. My knowledge above this kind of extends not too far. Can you give maybe just like a brief overview of like what RPC entails and where people also typically use it?
Yeah, RPC is kind of a vague term, but basically, in the simplest terms, what you do is that you want to invoke a function. Say, right, you have a function, for example, I don't know, get news, and you want to return a list of news. And what RPC as a concept says that you can invoke this function physically on another computer. And that's it. Being it a server or being it another service in the same cluster or anything, conceptually you're just invoking functions on another machines physically, and that's it.
So I think I know a couple of like players in the RPC space. There is gRPC. That one seems like one of the big ones, and then there's also Java RMI, like remote method invocation.
Yes, that's right.
And I guess now there's also kotlinx.rpc.
Well, yes and no. Yeah, you're totally right. One of the most popular by far is gRPC. It's a special protocol built by Google. They initially, I think, they built it for themselves for their internal usages. And if you, I don't know, scrolling around their documentation, you find a lot of sorry, don't use this for internal migration purposes. It will be here forever for compatibility reasons. Just don't use it. You will find a lot of those stuff there. And they built it for themselves, and they started to use it, and turned out it was quite nice. So they decided to open source this protocol so everyone can use it. And they made it kind of multi-platform, not in a way that we are used to when we're talking about Kotlin Multiplatform, but they just supported this protocol on a lot of different languages by themselves. And also now there are a lot of support from community for many more languages.
I mean, that makes a lot of sense because it seems like one of the like core things about RPC. I mean, it's kind of like the next step above like serialization, where serialization you have a bunch of different services, they all need to talk to each other, so you need some sort of interchange format. With RPC, it's like, well, probably you don't just need to exchange like messages, like you also actually need to invoke services directly. So having like another layer above that part makes sense. It also makes sense that it would be polyglot then, right? Like that you'd have multiple languages, because one team might build a service in Python and the other team might build a service in Kotlin, and they would still somehow need to talk to each other.
Yes, exactly. That was the thought, and that's why they created a bunch of different libraries. So you will find gRPC Java, gRPC C++, gRPC Go, and many others. And well, one of the also popular cases, when you have a basic client on your browser, it uses JavaScript, you talk to a server is probably not on JavaScript, but sometimes it is. And yeah, you have two different languages, they need to communicate somehow, they need to have this shared protocol. Protocol is pretty complex, so they supported it, so everyone can just use it, and now they maintain it, and it's pretty well documented, pretty popular.
So if there's already like REST as like a way to communicate, what is the like main use or advantage of like other RPC frameworks? Why doesn't everyone just pipe JSON back and forth through HTTP endpoints?
You can do this, yes. It's a matter of different purposes. So you have REST mostly for web services, for example, accessing resources, pages, and you want to describe them in a very human-readable way, in a way that you can easily trace and debug, and that is not too complicated to explain external users, but you need to have a certain level of maintenance for it. You need to monitor which endpoints you expose, how they are called, how they are documented, and everything like this. Like, for example, Open API probably is also good to be provided for it. gRPC is kind of another case. You can use it for simple client-server communications. Yes, sure. But I think the most popular use case for any RPC services is microservice architecture on your servers. The reason is pretty simple. There were a lot of monolith applications back there, and now that the microservices are getting popular, monoliths are also getting popular. They are playing back and forth, yeah. But for example, imagine you had a big monolith service, right? And now you want to have the same thing, but divided into a couple of microservices. And if you want to do this, you need to split the code base, you need to extract REST endpoints, you need to keep them up to date, and it is kind of a hard thing to do. You will need to update both clients and servers. If you had, you will probably still have a shared code base in the repository. It's not necessary, but you will probably do if you're just dividing the code base into different services. And what RPC allows you to do in this particular case is that you had this, for example, interface or class that was just working locally like a normal class or interface would. You would just invoke in methods, it will execute those methods, and everything run on the same machine as usual. But then you have now two microservices that were previously one service, and they are on different machines, and you still need them to communicate. And the easiest thing to do is just to put RPC in between, and your code base will change very, very little. You will just do the same things, but under the hood, you will communicate to another machine. And you don't need to build up the REST communication from ground up. Yeah, this is the most popular use case for RPC. But also, you can use it just for simple applications. If you don't want to, for example, build up the whole REST, think through the endpoints, you can just throw out RPC. If it's a good framework, it will be pretty easy to do, and it is actually a little bit more performant than REST.
Interesting.
Yeah, they use binary protocol under the hood. They optimize for the size of messages. And
protobuf, right?
Yes.
For gRPC specifically.
Yes, yes. For gRPC, you can use JSON also sometimes, if it's supported on the platform that you use. It usually is. You can use also JSON, and you can also usually use HTTP as a plain request. There are like extensions on top of the gRPC that allows you to parse HTTP requests into gRPC requests. It is also kind of a nice thing to have. If you, for example, want to expose one of your previously internal gRPC services into public usage, you can do this with HTTP. It's kind of cool thing.
I'm realizing that I know very little, so I'll have a lot of questions, and maybe they're silly, but I hope they'll clear some things up. You said here that gRPC can use can transform HTTP requests into gRPC requests?
Into RPC invocations, yeah.
Into RPC invocations.
Yes, yes.
Okay.
So basically, the message can arrive in the form of a gRPC message, so encoded in a standard gRPC format using protobuffers under the hood. It can arrive using other terms of transport.
Okay.
So, for example, HTTP, there are extensions on gRPC that allow you to collect those incoming HTTP messages, and internally they will be handled the same way that the plain gRPC ones would be.
Okay. So I feel like this lays a lot of groundwork. I have, again, like tons of questions, but let's maybe see if we can answer them in the context of kotlinx.rpc specifically. Yes. So what's kotlinx.rpc then?
Yes, that's a bit tricky question here because it's not a gRPC and it's not Java RMI that you mentioned. because it's not a protocol. We don't provide any specific protocol. I would call it a set of tools, a set of nice tools that allows you to use RPC in Kotlin. There are mainly three different components, three parts in which you can divide the library. The most important part is the part that is built by our compiler plugin. So it transforms the literal code that you write in Kotlin in a way that it becomes a gRPC or any RPC service, sorry, not gRPC specifically. So you can write, with kotlinx.rpc, you can write Kotlin interface, and you can transform it using our compiler plugins, and then use it in runtime without any additional configurations. So this is the part that I would call code generation or code manipulation. This is the first part of the library. It uses it transforms your code the way that you can use it as a RPC services.
So the code that I would write is the interface specification and the service implementation?
Yes.
And then kotlinx.rpc generates the machinery required so that another client that I suppose speaks the same RPC protocol will be able to invoke this specific service.
Yes, exactly. Just to sum up, you cannot, of course, there's no magic, right? In programming languages, you cannot just define an interface and call it a RPC service. It needs somehow to execute those methods. There should be a code that executes RPC requests. And basically, our compiler plugin allows us to make those RPC requests in a kind of standardized way for our library. So then those requests with all of the info about the servers, the method invoked with the data that the methods were provided with, it will pass along to the second part of the library and then used somehow for communication. And all of the code that is generated to pass this data for specific services that users write, it is generated by our compiler plugin.
Okay. So that's first part, code generation. You said there's three parts.
Yes.
So what's next?
Second part is runtime that we provide. It's kind of a thin part yet, but still very, very important. It's the basically runtime declarations and APIs that we provide that allow people to work with the services in a standardized way. So for example, there is an annotation that is called RPC annotation that you can put on your services, and it will transform them. There are methods that allows you to retrieve generated code in a standardized way. So for example, there's a method that's called withService. You provide it with the type of the service as a generic, and it will provide you the generated implementation of the service that is able to communicate. And it doesn't depend on a specific protocol that you will use. So this is the generic runtime APIs that allows you to work with those generated services with this code that was generated before that.
So with service, I would specify a remote service or a service that I have like a local service that like I am providing.
Let's just define what service is. So service is an interface, and if you're talking about kotlinx.rpc, service is just an interface that is marked with RPC annotation.
Okay.
Yes, and particularly for this function with client function, with service function, sorry, you provide it with this interface type, and it returns you a generated implementation of this service that is able to execute RPC messages. You don't need to write this. This API provides you with the access to generated code.
Okay.
And there's also things like RPC client, which is an interface that describes how clients work. So basically, the actual endpoint this interface can be implemented by users, or you can, for example, use some that we already provide implementations for this interface. You can use this RPC client, and it will actually know how to get those messages to the other side. And same with the RPC server, but vice versa.
Okay. So those were the two parts, and then there's one more?
Yes, the third one is kind of very important one, how the messages are actually transported between the services. I call this kind of a protocols part of the library. So protocols describe how messages behave over the wire. Or I guess it would be more right to say not over the wire, but between the services, because the services actually can be on the same computer if you wanted. So they don't actually need to be transferred using the internet or anything. That's kind of an abstraction level that allows us to define how they are transferred. So protocols, they describe how those messages, how those local classes with data will be transformed and sent to the other side. And of course, received on that side too, and then the whole process, but backwards. And currently we have two protocols in development. So we have gRPC integration. So basically, as we discussed before, we use our code generation to work with gRPC for the reasons why we can also discuss this. But basically, you can use our code generation and you can use gRPC methods of transporting those messages over the wire, and that's it. And it is under very active development, and but it works. It works. It allows you fairly simply to do those things.
What's the overall state of the library?
It's experimental.
Okay.
So yeah, the official state of the library is experimental because we are in a very, very active state of development. We are trying different things. We are changing, adding, deleting, and constantly talking with people what they need, what they want, and trying to figure out what will be the future stages, how they will look like alphabets and stable things. Yeah. And the second protocol. So the second protocol is kind of an interesting thing. It is our own protocol. We created it, and it was actually the first one that appeared in this library. It's called kRPC with a small k in the front. This protocol is not as gRPC. So gRPC is good for a very particular reason. One, it is popular. So there are two reasons actually. And the second one, it is stable as a protocol. So for example, if you want to use it in production, it's probably a good idea to use gRPC. Now our protocol is, as a whole library, is kind of in experimental state. Its advantage over gRPC right now is that it is fully Kotlin Multiplatform supported on both server side and client side. There are a couple of advantages, of course, because we're in active development. We decided on how to make it more performant, how to make it more usable, what to leave there for services, and if we want to maybe something drop is an idea. But basically, we look at those two protocols as kind of a different purpose things. So our kRPC protocol, in our minds right now, serves the purpose of being more extensible than gRPC is. Because gRPC is kind of technology that is feature complete. Okay. It just works and you can use it. And we look at our kRPC thing as the one that we can make really, really, really extensible by not so hard means. For example, one of the really extreme examples that my colleague came up with, my team lead, was that theoretically there's nothing that prevents you to use kRPC with, for example, Amazon SQS with the Q services.
As the transport layer?
Yes.
Okay.
So, for example...
Is there a reason why you might want to do that?
Well, we can.
I mean, that's
why I said it's kind of an extreme example. But the point is that we want to make this protocol really, really extensible for users. We want there's already a layer of abstraction that allows you to make the transport basically anything. Right now, it's only WebSockets because I only have two hands. And but yeah, as an idea, it can be really, really extensible, and it can use different means of transport. And it can be also extended. It cannot right now, but it should be, as our idea, to be extended also in the code-wise side. So we're thinking about plugins for it, how people can extend the messages. Maybe they want to, for example, modify the message payload before sending it, but they want to do it in a standardized way. So for example, if somebody uses Ktor, there are things that are called pipelines there, and you can use different plugins to transform.
It's pipelines, interceptors,
Yes,
middleware,
yes,
like
yes,
the
yes,
classic kind of like transformation
Yeah, a
like
lot of
steps.
things. You can do basically everything you want in Ktor there with those transformations. The kind of the same idea we have for RPC here.
Okay. Now there's like 100 rabbit holes I wanna dive in with you here, but let's just dial back onto one. Probably, I don't know if it's a hard question, but it's I think one that needs to be answered. We talked beforehand and we said it's like a lot of the use cases of RPC revolve around interoperability, right? I have a Python service, I have a Kotlin service, I might want to have them talk to each other with an RPC call.
Yes.
You said there's like gRPC as a protocol is in the works. So help me understand a little bit like what this scenario like might look like. Is that something that will be supported with kotlinx.rpc?
Yes. So if you're talking about Python services in particular, for example,
I'd hope like my hope would be that if I had an established like gRPC system that has multiple things calling each other, that I could plug in a kotlinx.rpc thing and that it wouldn't stick out.
Yes. So see, let's just look at a bit bigger picture. You don't have just two services.
Sure.
If you have like a huge system, you have hundreds of services that talk to each other, and some of them are written in Kotlin, some of them written in Python. And if you have just two services, one in Python, one in Java or Kotlin, there's like not a lot of advantages of using us because you don't have this.
But I could.
You could, yes.
Okay.
Yeah. Yes, you can just write a gRPC server in kotlinx.rpc. It will just work.
So it's just like I create a specification of an interface in kotlinx.rpc. I provide an implementation for it, and then through a series of Gradle tasks, like out falls a like RPC definition file. I don't know, .gRPC file or something like that.
Yes, there's a .proto file.
Okay, yes.
.proto file. You will just use the same .proto files for your server for Kotlin to generate code, and the same proto files for your Python services.
Okay, so then like I just feed that into like the client or like the code generator for the Python side, and then they can just like ingest that and.
Yes.
Great. That's already like that's because that's I think the important point that people always need to understand when you're talking about a new RPC framework. In this case, again, like you kind of called it more like a toolkit, almost or like an SDK. It's not like a reimagining of the entire stack. Certainly not necessarily. But it can actually plug into all these things.
Yes. The idea is to make it much more easier to use RPC because always you will need to have a couple of extra steps to set up correctly everything and to use it on a daily basis. So with the case of Python service and Kotlin service, there are not a lot of good points to use kotlinx.rpc. There are still, for example. If you use Kotlin on server and you use standard gRPC Kotlin code generator, it will use also gRPC Java. They are coupled there. And the problem with them is very, very simple. They're great technologies. They work perfectly and they're well maintained and well documented. But the code that is generated is enormous and impossible to read. So, for example, if you define a file that have just one service, and one type of message or two type of messages, something like this, it will be 23 lines or 22 lines of code in .proto file for a service definition, pretty small service. It will generate you 1,000 lines of code in gRPC Java in one file.
That's a lot of code.
Yes, they don't separate internals from user-facing declarations there, and it is hard to read. And if you have big enough proto file, your IDE will freeze.
Okay.
So that's also the thing that we are working on in our gRPC integration. We are separating internals and externals, and in our side, the Kotlin file will also be roughly the same size as the proto file. Yes, and this is just for case with the Python services because you don't have two sides that talk in Kotlin. If you have two services that talk in Kotlin, For example, you have a KMP application, you have Android and your service, and they are both in Kotlin. Or you have just two services on the server side that are both in Kotlin.
That seems common enough.
Yes, yes. The one thing that for you as a developer that would be very, very beneficial would be that the code will be literally shared between them. So if you're using kotlinx.rpc. So if you're using just gRPC, plain gRPC Java thing or plain gRPC Kotlin thing from the Google, what will happen? It will generate two separate classes. One will be called your service something named stub, and one will be called your service something named base. And the first one you can just use, you will instantiate it, and you will be able to call your methods on it. Second one you will need to implement, and you will need to implement the methods, so basically the work that should be done when the method is executed. The problem is they are not really connected to each other in a type system. So for example, if you are, I don't know, in a client side code base, and you see the usage of this method, you go to implementation, you hit the button that says go to implementation in your IDE, and you are now in the rabbit hole of generated code. And if you are able to find everything that you need in this file, which is questionable, but still, okay, let's say that you managed to do this, you will need to still spend some time to find the implementation of this service, right? Because it's the separate class, it's implemented separately, and the IDE will not help you with this. And even if it can, it will be like a fix on top of how the system works initially. But with us, you will just have the same interface there and there. You will have the same interface on the client, the same interface exact on the server, and you will just use it as your regular interface. You will just hit the go to implementation, and you will go straight to the server code from the client code, just like this.
So this, like the scenario here would be like I have a monorepo, I have like a whole bunch of services, and then for like the RPC definition layer that lives in its own like API module, so that, you know, if I'm in the client, I hit like go to definition, it sends me into the API module, I right click find usages or go to like implementation or whatever. All the IntelliJ features, for example, just the IDE features in general, they'll all just work. Well, I'll get full insights.
Yes, yes.
That's very cool.
That's very cool, and that's actually one of the things that kind of prompted me and my colleagues to start the project. You see, when I joined JetBrains, I worked in a space team, and they had their own RPC framework there. And it was working kind of the same as the kotlinx.rpc right now. I mean, in terms of idea, right? In terms of what I just described with this go to definition things. And I was an intern. I had no previous experience working with RPC services. And I didn't even know like exactly what RPC was there. I was just using those interfaces. I was going between client and server code. It was just so seamless and so easy to find and change whatever I need, to add new functions, to go to see how the server implementation looks like, why something from my client side doesn't work. It's just so easy and it just so works that I think that's why we're creating tooling, right, for developers. Because it makes your life so much easier in this ways. It may be simple stuff, just having the same type for the server and the client. It may seem simple, but it really makes a big difference when you develop with the services.
Yeah, and I mean it's kind of like full stack type safety, kind of like in a pretty cool way.
Yes,
that's really that's really something. So Kotlin is naturally like a very powerful and very expressive language.
Yes.
We talked about the fact that you can also use it in a polyglot use case, like with, I don't know, Python, JavaScript, whatever is supported by gRPC. And we can also use it just with like other Kotlin services, and those can communicate very well. Now, when I played around with kotlinx.rpc at some point, there was something that was quite cool, which was like being able to have flows as part of your like RPC.
Yes, so RPCs typically have two types of requests. They have simple plain requests.
Yes.
You send data, you wait for an answer, you get the data back. And there are also streamings. Now streamings are basically continuous flow of requests, and it just closes when you need it, or if you don't need to close it, doesn't close. You just continuously get the messages from the server, or you continuously send them from client to the server, or you can do both at the same time.
Okay.
Yes, that's a pretty cool thing, and it is supported using flows in Kotlin because they're just natural to do this.
So is the entire thing just built on top of coroutines?
Oh, that's the question of what you use under the hood.
Okay.
Yes. So from the code generation side and core runtime API side, it is flows. And how they are internally, it's an interesting thing. If you use gRPC, they have support for Kotlin, and they're also using flows there for streaming. And they they suspend the blocking calls and use coroutines on top of Java's implementation. So for gRPC Kotlin, they also using Java runtime anyway. And we'll do the same because it just makes sense. We don't want to write whole new runtime for the gRPC. It's ridiculous. It doesn't need to be done. For our protocol, yes, we're just using coroutines everywhere there. We're using plain flows there, and it just seems to work fine. You have proper cancellations there. You have sometimes bugs, but we're trying to fix them. Yeah, there were big debate about should we allow state flows and shared flows there, for example. And initially they were supported because we wanted to do something. We wanted to do a lot of cool features, and then we started to thinking after we supported. Yes, and
that's the good part about being in the experimental phase, right?
Oh,
You can try something. You can see that something has a problem.
Yes, that's true. Basically, all of the features that were recently deprecated in services, including nested flows, so where you can send the flow of flows. We were able to do this just because it was cool, and we were asked to do this. And state flows and shared flows, they were all deprecated right now in kotlinx.rpc because it turns out when you're trying to do those stuff, you have either the problem of scope, so how long does your flow live, where should it end, how you should use it, how you should close it. It's very untrivial to solve in those cases if you have. Or it is a problem of distributed state, which is an enormously hard problem. And we don't want to solve it, at least just yet. So basically, if you're trying to make a state flow, you already have some kind of a distributed database. And we don't want to do this. We decided that we are not going to do this. We'll just leave plain flows. Plain flows, you send a message, and you eventually receive it on the client side, and that's it. Yeah.
So I have, so at my disposal, I have simple functions.
Yes.
That I can call, and I guess they're suspending functions. Okay. And I have functions that can return flows.
And yes. Right now they are suspending. This will be deprecated, and they will be just regular functions. So you will just return a flow, and you will collect it in the scope in which you need to collect it. Yes.
Okay. So in this scenario, you would, like, the first emission would just be slightly more delayed. Like I can, because conceptually I can like somehow understand even now why it would be a suspending function, because it would be like, well, you kind of need to establish like now we have a channel through which we can send flow items, and then once that's established, you have like a flow.
Yes.
Okay.
Yeah, the problem, if you have a function that returns a flow and it is suspend, it is really easy to misuse it. So it can work fine. It can work just fine. But the problem is it is really easy to create a foot gun for yourself. And that's what we're trying to reduce. Those possibilities, we're trying to reduce them, because if you have a suspending function, you can call this function in one context, you can collect the flow in another context, and you will just spend a lot of time thinking, what is the lifetime of this flow, how it works, when it stops, and it will be really easy to make mistakes there. That's why we're trying to simplify things to a level that is easy to use, but still very powerful.
And from there, they kind of just behave like regular, like suspending functions and functions that return flows. Like I can cancel them.
Yes.
Like they're part of like a scope. Like I can throw them in my coroutine scope and just everything like that. That just all works.
Yes, yes. Basically, you will collect the flow. If at some point you decide that you don't need this flow, you will lose it.
Stop collecting.
Yeah, you will stop collecting. It will be in some time collected by a garbage collector. The flow disposed, the stream disposed too.
Okay.
Yeah, it's kind of a tricky way here because it is not guaranteed when this object will be collected by a garbage collector. So it is, you cannot like influence, at least now you cannot influence when exactly the flow will be closed and consequently the stream of the messages. And that's why we are talking with a lot of very smart people here in JetBrains who already work with this RPC a lot and trying to figure out what will be the best way to handle this and other many cases here.
That sounds tricky. I have to say, because like overall, like the I guess it's not so like you can easily imagine a situation, I guess, where you might still be sending things into a flow, but like the other side is already no longer interested.
Yeah, that's a tricky situation. Actually, the one easy way to solve this would be to use channels.
Okay.
It just turns out that people don't really like channels, and they want flows. Yeah, in flows you have less built-in instruments to control the lifetime. It works fine on the local machine.
Yeah.
It works actually excellent. But if you introduce this uncertainty between two machines, it gets trickier.
Let's dive right into that a little bit more as well.
Okay.
Because I think so I recently went through the Designing Data-Intensive Applications book by Martin Kleppmann again.
Okay.
And he has a like lukewarm perspective on RPC in general. But I think his one of his main like criticisms is that you're making something look like a local function call when it's like fundamentally not, right? If you have a call to a local service, right, that's just a function call, and that will most likely always return with a somewhat deterministic like time of like how long it will take, and it will certainly return as well. Which in a network situation, like immediately, that might not be the case, right? First of all, you might have like pretty strong like fluctuations in like network latency. Probably not if you're in the same data center, but like you said beforehand, if you are using it in the scenario of a of like a mobile client or something like this, it's an entirely different story. And then of course you just introduce kind of a new class of errors. You now can have timeouts. You might have situations where you invoke a function, but you as the client can't tell anymore whether that request actually went through and like whether that actually was applied, because for all you know, you might have sent the network request, someone might have cut the cable, and you just never got a confirmation back that the function is done. Now I want to be before I want to dive into this, I actually gave this a little bit of thought, because I feel that Kotlin is somewhat in a bit of a unique position, because it seemed that the perspective from the book is very much assuming that everything is like a regular like function call, which in our case with kotlinx.rpc it's not. It's a suspending function call, right? Which is like kind of what you do for network calls anyway. Like you're expecting that these can be canceled, and you are expecting that maybe they take longer, right? They're suspending, and all these kind of things. But yeah, I'm curious.
Yeah, well, definitely there's a part that says that we are hiding some bit of complexity. That's true, but that's kind of the point of RPC, to hide complexity, to make it easier to make the services. Now, about the errors and about your mental model of how this works. Yes, it's true that it's actually making a network call and something might go terribly wrong. And to handle those situations, you would do two things that you do in any other situations when you work with the servers, when you work with the network, sorry. you design your services in a way that they can be fault tolerant, that they produce responses that indicate how the operation went. For example, if you're doing some database query, you're creating a new user on your application, you send in the query, server receives this, goes to database, doing this stuff, and something went wrong. You need to have a good system of handling what went wrong on your server and then communicating it to a client anyway. You will need to think it through anyway. You're using your RPC, using REST, or anything else.
Yeah.
And the second thing is our obligation is to make sure that the communication is transparent. If something is cut off, we should throw an exception that is possible for user to understand what it means, what happened. And we're trying to do this kind of, yeah. So we're trying to make those communications and errors and cases more transparent. Of course, for example, if you're making plain request with Ktor, right? You have this get function and you have headers there, you have a lot of fine-grained control on your request, how it should behave in such cases. You can configure timeouts, transformation, everything. It's not the same with RPC, but it is probably just not needed. If you need to, some level of configuration can be moved out just to another place, and it will be still available there. Some level of configuration will not be available as in REST, but again, it's not REST. You don't need all of the things because many purposes are just different.
Yep.
If your goal is to build a service that can communicate, that is fast, that is easy to code and easy to evolve, RPC is just fine. If you need something really specific, probably REST will just solve your questions or your problem.
I think really this is the key point here, probably, or the key insight that I also kind of take away for myself here is you can't look at RPC as like a magical, like now it's a local function call. Yeah. Like you really still just have to look at it as like I am exposing a service, but this time we're doing it in a type-safe manner, like using a protocol that is not necessarily just like JSON over HTTP. And if you look at it from that perspective, if you still remember that like item potency is important because, you know, a client might send the same request twice because it's not sure whether the first one went through. Or the fact that, you know, if you send a response, that response might not necessarily be received. Like all these kind of things. If you keep those in mind, like you can still build with RPC just the same.
Yes, true. And for example, with RPC, configuration is usually moved out of the call side to the service definition side or client definition side that handles this service, right? And if it so happens that two requests, two methods in the same RPC service need to behave so differently that they need different configurations, you just make two services and nothing changes drastically. Well, if you need to migrate, then it's kind of pain in the ass. But still, you can do this, deprecating here function, using new function with new service, and it will have different configurations. That's it.
Sweet. Pretty nice. I have another rabbit hole to get into.
Okay.
There was one of the three parts that you talked about was the transport layer.
Yes.
And I think you mentioned that there's some sort of like kotlinx.rpc being like agnostic of the actual transport layer implementation.
Yeah, that's true. We have two main extension points, if you can call them, is RPC client and RPC server. These two interfaces, they're really simple, at least right now. Maybe they will get more complex further in the future, but right now they're pretty simple. They say two things. First of all, if it's RPC client, it says I can manage a couple of services and I can take the requests from them and send them to the server. That's what I do. I'm RPC client. Same on the RPC server side. I can manage a couple of services, and I can distribute incoming requests to them. That's it. And how you implement those two interfaces is kind of, well, problem of the implementation, right?
Sure.
Right now we have 2 or 3 implementations, depends on how you count them. We have gRPC that implements them and uses gRPC protocol there. We have kRPC that also implements them, and it has its own kRPC client and kRPC server.
Yep.
But if you're talking about kRPC, there's one more layer there, because there's also a thing that is called transport. Now, kRPC handles the protocol part, its protocol part, how it distributes, encodes, and decodes the messages in those two implementations, in kRPC client and in kRPC server. But they also use kRPC transport under the hood, the one that actually sends the messages over any medium.
And that's like another interface?
Yeah, it's just another interface.
And at that point, it's just like binary, or?
Yeah, it's just you send in strings or just bytes, and you're receiving them, and that's it. Basically, your work is done here. And right now we have one over WebSockets using Ktor. So it is coupled to Ktor. And the second one is not public. It's used in one of our internal projects in JetBrains. They build it over SSH.
Okay.
Yes, they needed it for some reason, and they built it over SSH. I don't know a lot of details about this because they are complicated there. They need it, and they are really working on this system there. About the Ktor one, it's just working over WebSockets. It's pretty simple there. It's just sending string requests, encode it, and then kRPC instances, either client or server, decodes or encodes them as they wish. And the nice thing is for Ktor specifically, you can just define a new route that is called RPC route. We provide the extension for Ktor that is called RPC route, and you can, if it's a server, and you can put your services just there.
Yeah.
And they will work as is in new applications or in already existing ones.
So I can just, if I have a Ktor app, I just do like an RPC.
You just add the new route.
Okay.
Yes, and you define your services there, and it will work alongside with any other things that defined on your server. And on the client side, when you get a Ktor client instance, it's called HTTP client, I think there. You invoke get methods or post methods on it. Well, you can invoke RPC method, and it will return an instance of RPC client. And then you can use this instance to create the services and use the same client to send those requests. And under the hood, it will be just WebSockets communication.
What does it do if I request a service that is not offered?
It's a nice question. It can wait or it can fail. You can configure it. Yeah.
Ah, all right.
Yeah. There's no way to configure it how long it will wait, but again, we're experimental. We're working on it.
Sure.
Yes.
One step after the other. No, that's really cool. So you're telling me that if I pick kRPC,
yes,
I am completely free to choose whichever transport protocol I want to use.
Yes, you're completely free probably to implement one if you don't like the ones that we provide.
Well, I'm just thinking, like, if I have, let's say I'm on the same machine and I need to communicate between two processes, I might go through, like, I don't know, a file descriptor, like standard in, standard out for like the other process.
Yes.
Something like that.
You can do this. Yes.
And that just works. Wow.
You can just implement this transport and it will just work.
Wow. But that is exclusive to kRPC. I couldn't do this with gRPC.
Yes, you cannot do it with gRPC. With gRPC, there is another story. They also have this kind of an abstraction. So they also support different types of transportations, but which ones are totally dependent on the gRPC that you use. So I know that they support, by default, it's HTTP2 that they're using for requests. They also have support for plain HTTP, so they can parse plain HTTP request without gRPC specification. And there are some others. I'm not sure. Maybe they can also use WebSockets, but I'm a little bit Wagyu here, you know.
Okay.
Yeah.
Yeah, because like the one part that we talked about this like over lunch earlier, was that what surprised me a little bit was that RPC does not necessarily mean like remote. Like you said, RPC sometimes also just happens on the same machine. Like when you have your project, say for example an IDE that's written in Kotlin, that maybe needs to communicate with some specific system APIs which are not that enjoyable to access using like the Java native integrations. So instead you might have some sort of like service that's written specifically for a platform that then does just like an RPC communication together with like your Kotlin service.
Yes, conceptually nothing prevents you to do this. Yes, there are of course like practical obstacles. Right now, for example, not all of our interface that we provide are quite extensible, but we will work on it. I hope so.
Are there plans for kRPC, the
Yes.
protocol, to also become like polyglot, to also support other languages, or is that purely for Kotlin to Kotlin communication?
It's mostly for Kotlin to Kotlin communication.
Okay.
Yes. And the thing that we want to do with it is we want to make it extensible in a way that somebody else might want to support this protocol by themselves for other languages, but we will not aim for other languages. We will aim for extensibility.
Okay.
Because we don't have like so many employees as Google does, and we cannot like have all of the languages supported or even major ones. So our focus is Kotlin to Kotlin communications,
Yeah.
Kotlin Multiplatform in particular, and extensibility. So for example, if you want your service, it's actually a real life example. It is from my previous position that I talked about. In space, we had a server defined as an RPC server, and it could communicate to your client in the web, basically your web page, using this RPC, right? And it was just working over WebSocket, I think. But also, you can invoke the same exact methods, the same exact function implementations on server using plain HTTP requests. So it can just parse your plain HTTP requests in JSON and maybe other formats, and they will be transformed into the same exact calls. And conceptually, for the server, they are the same. And that's the kind of extensibility I'm talking about, right? So you will be able to parse different inputs and make them work still with our server.
Okay.
Yes. And of course, we will try to develop a protocol specification that is not that hard to support on the other side. But that's
sense.
In the future.
The story with kRPC, the protocol, and Kotlin Multiplatform, that part seems clear. What's the connection with the gRPC and Kotlin Multiplatform? Is there anything there?
Yes, gRPC and Kotlin Multiplatform is basically the reason why we started to work on gRPC. Because, you know, it's nice to have better code generation. It's nice to have shared types between your services, but it's not vital. People live with it just fine. It's just the things that we can do and we will do because it's not that hard to do. It will bring better user experience. But that's not the reason to make the whole gRPC integration. The reason is it's kind of hard to use gRPC fully Kotlin Multiplatform right now. Okay. It's easy for Java, right? Kotlin JVM, just fine. It's kind of harder for Kotlin JS. So you will need to define a lot of external types, and you will need to write Kotlin JS because you will need to use gRPC dependency for gRPC JS dependencies. It will still work. Now, if you want to make it work at Kotlin native, you have a really big problem there. And I'm not talking even about all of the build configuration that you will need to do for this, because there is nothing that will help you with this out of the box. It will be just one big nightmare.
If you're doing pure gRPC.
If you're doing just gRPC, it will be one big nightmare to do. To make this work, gRPC, how would say it, the main, I would say, implementation of gRPC is written in C++, the library. And there is no library in C, in plain C. Kotlin native works with plain C.
Yeah, that's all the like C like ABI application binary interface stuff, right?
Yes.
Yeah.
Yes. So what you will need to do as a person who wants to use gRPC in Kotlin native, for example, for iOS or for desktop applications, you will need to transform C++ library declarations into C, writing some intermediate files.
Yeah, I'm already out.
Yeah.
I'll be honest.
You will need to write C interop definition files to make those C declarations that you just created for Kotlin native to pick it up. You will need to build this, you will need to maintain this, and you will need to update all of those places every time you want to make a change.
Yeah, okay. And I don't think anybody can be expected to reasonably do that.
Yes. And that's why we just want to make this work without any other special configuration. So build configuration will be done for you. C interop will probably be done for you. It's still a very hard problem, and we are planning to start working on it in the summer, and we will even have help for us from people who know something about native, because I'm not very knowledgeable about C++ or C thing. We have people who are, and they will help us making gRPC really multi-platform. And we will want to automate it, because you see, gRPC is a polyglot protocol, right?
Yeah.
It's kind of expected, at least in my head, that it should be amazingly good with Kotlin Multiplatform, because the idea is the same. You write in your interface in Kotlin common code, and you use it everywhere without any configurations additionally on top of this, right? And it just works perfectly.
Yeah.
Well, that's what we're trying to do. That's the main reason why we're doing gRPC. And all of the other stuff is just things that we are also trying to do in a way that will be really easy and really nice to use.
That's really, I mean, from that perspective, I feel like we can almost look at this as like a foundational technology again, right? Like, right, it's kind of it's a core part of the Kotlin ecosystem, simply because it makes you able to like do these things which otherwise you probably would you'd take a look at it and you'd go, that seems a little too much work for the payoff that I'm getting. Whereas if it's just start writing, like it all of a sudden becomes a lot more attractive. And it also maybe becomes more attractive if we're looking at like when we say multi-platform here, it doesn't necessarily also have to mean like mobile, right? Like Kotlin native, you can also run that on a server. You can also run that on a desktop. Like that can be anywhere.
Yes, you can make some embedded devices, run it, and communicate to your home server.
Yeah.
That is run on JVM. Yes.
Yeah, that makes perfect sense.
Yeah. So just to recap the plans here, right? Right now we have development implementation of gRPC, right? It is in like it is previous state for experimental library, so it's like extra experimental because people were really eager to try it out, and we decided that we will publish dev builds for people to consume them, to try them, and we're actively making the JVM part good and working. Then we will go to Kotlin native part, specifically focusing on iOS, but probably all of them together, because we will try to do it with the C++ implementation. After that, we will look into other platforms. So right now JVM, then native, then after that we will see how our priorities go.
Okay, that makes perfect sense. I guess overall that also gives us kind of an idea of like, yeah, you said it's experimental, but I very clearly getting the vibe here that probably this is something that people should play around with, but probably not deploy in their production applications at the moment. Like you said, there's a lot of stuff that's in like the design phase. You're throwing things out when you realize that the complexity is too high. You're kind of like zoning in on what makes the best like user experience and something that can be like supported in a very solid way. So I'm guessing really it's like for external folks, it's certainly kind of in the playground stage, right?
Yes, exactly. Although we already have folks that are asking questions like, we're in this company and we really want to use this thing, like in our production code, like yesterday. We already want it yesterday, and I'm, it's kind of hard to say them, please don't, but
Yeah.
sometimes I need to.
Well, it's inspiring at the very least,
Yes,
right?
yes, that's true. But that's actually also why gRPC thing is kind of good thing, because having a stable protocol and not so stable runtime API is much better than having unstable protocol. Because having unstable protocol means huge headaches for your development cycles. Having unstable APIs means that you will need to refactor code more. That's doable, right?
Yeah.
So that's why we're trying to make gRPC faster, so that external people can use it in their production code without so much worries. And that's why the kRPC is kind of in a phase that we are maintaining it, and we want to fully focus on it after we have another alternative stable protocol for people to use.
Okay.
So right now, you can play with it. You can write your pet projects with it. Some of our internal projects use it pretty seriously, but they have advantages that they can just go to Slack and DM me a message saying that I broke everything for them and I will go and fix it. Not everybody has that in the world, right? Of course, we are taking our time to make the transition as smooth as possible without like too much waiting time, but also not making migration processes painful later.
That makes sense. So far, we've talked about how I can define all my services with a nice Kotlin interface, throw that RPC on there, get all of that stuff. Is there any way where if I have an existing system of like, let's say I am a Kotlin client that would like to consume a Python, JavaScript, Rust, whatever service, and that service gives me the like proto definitions, right? Is there a way that I can get these proto definitions and that gRPC definition like into my kotlinx.rpc?
Let's see if I get it right. Do you mean dynamically or what?
No. I just mean like building against a service where I am given the definitions. Because so far we've kind of talked about the state of truth being like this RPC interface that I write and then like proto gets generated and
actually no, there was a little confusion. For gRPC is the other way. So proto is still the source of truth right now.
Okay.
Yeah, let me just talk a little about this. Yeah, for kRPC, importantly, source of truth is Kotlin interface.
Okay.
And it will stay so. The only thing that may change is that we are thinking about adding some manifest that will allow to track changes in the services. So if you change something, the change will be tracked in this manifest. But source of truth will be your interface, and it will be designed so that the tooling around it will not require you to make changes twice.
Okay. This makes sense to me in a Kotlin to Kotlin perspective. Makes perfect sense. The Kotlin interface is the state of truth.
Yes. gRPC is another thing because everybody uses protofiles. Protofiles are the source of truth for now.
Okay.
And for most use cases, I would say serious use cases, it will probably stay the same because it just makes sense. You track your changes there in these protofiles. You track, for example, such things as proto numbers, the reserved ones, the deleted ones. All of those things are tracked there, and it's a nice format. It also has some support in IntelliJ, and it works good. But sometimes you just don't want it. I mean, if you have small project that you just want to use, and you have some external gRPC service.
Yeah.
And you would just want to play around with it or just write for yourself. You don't need to have long-term support. In this case, we are thinking about making it optional to have proto files. And in this case, the Kotlin interface will be the source of truth for gRPC also, but it's not such a priority, right? We're trying to prioritize things from something that we cannot live without, and then something nice a little bit later. This is something nice to have. Yes.
So this is actually super interesting, because so the scenario that you're telling me now, and I guess I maybe just made the wrong assumption here in the beginning, was it like if I have a service, it offers me a proto file, I guess I throw that into like my resources directory or something like that, hit with a Gradle task, and then it'll just generate via the compiler plugin like the actual like RPC interface from that?
So it's, well, depends on when you ask me. If you ask me right now, it's a bit different. If you ask me in a month, it may be also, the answer will change probably.
Things do have a tendency to change in experimental projects.
So yes, true. The thing that will stay the same for time, not for time, but probably for the whole my life, I guess, while working on this project, is that when you have a proto file, you will be handed a generated source file with the interface for it, and just interface and maybe other classes for the message types. Everything else, how is generated, so we're talking about internals, right? How it all works. It depends. Right now, it is also generated as source files, just in another place, so we don't pollute the actual file that users will be looking into most of the time. But and it is generated as a source. We just write Kotlin files, and then they are attached to a compilation process, and they are just regular Kotlin files. Probably this will change with time. And there will be no source files, and all of this code will be handled through a compiler plugin. This is the kind of thing that it will be nice to have, because it will not pollute your code base, and it will also allow for more interesting things using a compiler plugin. We will also talk about this.
All right.
I will ask myself questions to answer that.
Perfect.
Yes, and but right now it's low priority, because we already separated those files into different places so they don't pollute the scope, and we are focusing on making the gRPC feature complete, and how the code is generated is kind of the second thing. Yeah. But again, the most importantly, you have a proto file, and here you have a generated interface associated with this. That's it. The thing that I talked about is that...
So here the scenario is also if I write an RPC service, like a server, I would write the proto file first and then generate the interface from that and then implement the interface in Kotlin.
Exactly.
Very good.
Yes, exactly. And if we are talking about the thing that we want to do without proto files, it will be just without this generation phase. You will just write the interface yourself.
But yes, but this is actually one of the big points, because I remember that historically in kotlinx.serialization, which also has some support, I'm not entirely familiar with how deep it is, it has some support for protobuf.
Yes.
And here the source of truth was always the @serializable data class, like the Kotlin declaration that would spit out like a proto file.
Yes.
Which is like fundamentally the opposite direction.
Yes, that's the opposite direction.
And as such, also means that it's a little harder. Like you kind of need to do some reverse engineering if you want to consume a proto file that you are already given.
Yes, that's true. Yeah, and that's why we went the same way that everybody who uses who implements gRPC or protobuf generators, we use the proto file as a source of truth. Because it's easier to maintain it like this. Everybody do it like this. You don't need to do any mental gymnastics here. Yes. The other thing that may be helpful here is that in this case, you always have one more extra build step, right? So before the changes in protofile are reflected in your Kotlin interface, you will need to execute special build step. For example, in Gradle, it's something like generate proto. It's not, again, it's just kind of a quality of life issue thing, but we are also thinking about trying to make it not needed, not necessary, this step.
That's just part of the compiler plugin again?
We will see. I didn't look into this yet. I'm not sure how compiler plugins. Probably it will be an IDE plugin for the reason that you would want to look at the source code. And if you're using compiler plugin, you will not be able to see the source code. And that's kind of not convenient. Yeah, because it will be generated. The IDE will know about its present, but if you want to go to definition of the service, you will go nowhere because there is no source file for it. Well, what probably will be done is if you worked with SQL Delight.
I was about to, that was my next point, was exactly this, where, because this was exactly the experience I was envisioning. So for context, if we have a SQL Delight thing or a project, you would define your queries in like a .sql file, and that would then like generate type-safe accessors in Kotlin. But the cool part that I assume you're kind of playing towards here is that you can absolutely command click one of the like accessors, and it will send you into like the SQL file where that specific query is defined, or you can find usages as well, which is supported by a IDE plugin.
Yes, and also this IDE plugin allows them to compile this SQL files on the fly without executing any build steps, which basically making coding process a little bit more smooth.
Okay. Yes. All right. So I don't know too many details here about the depth of this, but will the new like K2 like compiler APIs, like the analysis API and so on, will that make any changes that might make this superfluous, like that might make this not needed?
They are probably not for this task at least.
Okay.
Yes. So the fundamental problem here is that again there will be no source if we're generating from proto files. There will be no source. The compiler plugins really come into play here, and specifically FIR plugins, when we want to modify existing code or add something to it. That's the place where they shine, and that's already the thing that we are using. So we can talk about this.
I would love to. Yes. You said you wanted to ask yourself some questions about this. So
yes. So Alex, what makes our compiler plugin so special here? I'm answering. The thing with compiler plugins is that the compiler plugin API is not stable. What it means for developers of compiler plugins is that if you want them to be used in IDE, for example, so that the IDE can understand what did your compiler plugin made on the flight without any build changes or without any red code, well, you're kind of in trouble. It is just not supported. The reasons are very, very technical, but to simplify it, the code completion that you see in IDE, so for example, if you write method.something and then you see a list of properties, class.something, you see a list of properties or methods, what happens there is that your IDE runs a separate version of compiler that just does this a lot of times incrementally, probably, to make it efficient, and so it knows about everything that happens in the code, right? But the version of compiler that you use to build your project and the version of compiler that is used by the IDE are not the same. And because the API is not stable, they're not compatible by default.
Okay.
So you cannot just use the same compiler plugin there and there. And to make this work, you need to make a lot of things, and not just in code, infrastructure-wise also. And we did it. Basically, we did it. We created a couple of things that allow us to make our compiler plugins work in IDE in a stable manner. So right now, there is if you go to the, for example, in IntelliJ, if you open the IntelliJ registry, there is a property that you can tick that says use unsafe compiler plugins. And all the compiler plugins that are applied to a project will be used inside IDE, but there are no guarantees that they will not just fail.
Okay.
And I just know that there are some projects from the communities that use this option, and it is fine, but sometimes it can just break unexpectedly, and there's nothing you can do about this. Now, we made it stable using infrastructure things and using the little help from the Kotlin IDE plugin team. They helped us making this possible. They made an extension point for us. And what happens is that now we can use this IDE support for FIR plugins stably, and that makes the coding process so much better. So for example, we have the thing in the kotlinx.rpc that we call annotation type safety. What it means is that there's a regular type safety writing. I will try to explain it quickly. And there is a thing that when we annotate our service with this RPC annotation, right, we generate a bunch of code for it, and we generate it specifically for this interface. And for example, there are methods that are designed to retrieve the generated code. So for example, we talked in the beginning, there is the method that is called withService that accepts the generic, and you should pass your interface there so that it can retrieve this generated code. Well, in plain Kotlin, there is nothing that says that you cannot pass a subtype of this interface.
Yeah, just any subtype.
Any subtype of interface, including the server implementation, for example.
Okay, yeah.
Well, it will fail in runtime because there is no generated code for this particular class. Well, annotation type safety basically says that this particular class that you are putting here as a generic type that will be resolved should be annotated this thing. And if it's not, it will fail in compile time.
Okay.
Now, it's nice by itself already. It helps you to detect runtime errors in compile time, possible runtime errors in compile time, but it uses compiler plugins there. And for example, you have a code base, and to detect all of such problems, you will build, you will see that compilation failed, and you will go there and you will need to fix it. And again and again and again until you fix all such problems. It's not that good, right? And compiler plugins in IDE allows us just to highlight this code as red as any other uncompilable code the same way, and provide some meaningful message that says that you cannot do this. So at the time that you will write this declaration that is basically violates the rules of our services, you already will see that you are wrong, and you will quickly correct yourself.
This is, I think, actually one of like from a developer experience perspective, this part is always amazing, because for me, there's nothing more frustrating than seeing code that it looks like it should compile because there's no errors.
Yes.
You hit a button and then you get an error. For me, this is like, I find myself very much in tune with the IDE. Like for me, this is actually one of the things. Fortunately, this has essentially not been a problem in over a year or two. But back when the quality of Kotlin tooling was struggling a little bit more, one of the interesting parts that I actually noticed was the inlay hints that I have, the little type hints or the parameter name hints. They actually gave me a really good indication of whether the IDE currently understood what was going on in the file. If I didn't see inlay hints, which seemed to be very far in the end of analyzing the file, if I didn't see those, I was like, okay, something with my setup is kind of funky. I should probably address that first, because until my development environment understands the code again, if the IDE doesn't understand it, then I'll run into exactly those problems, even on a more basic level. I'll just write something that doesn't work, and I'll not know until I hit run.
Yes, that's true. And also there's exactly opposite situation when the red code actually compiles,
yes.
But your IDE doesn't understand this. This is the part that, for example, if we want to provide extra code generation for messages, the code will be just red in your IDE if you don't have working compiler plugin in there, right? But it will build, and it is just so frustratingly terrible to use.
Because again, it's the situation of like you give the developer doubt, right? Like they look at it and they start questioning, did they do something wrong? Did something, and it also immediately, like, if that happens too much, you kind of train yourself for the reflex of like, I'll just run anyway, and I'll just see if it works. But then if 80% of the cases, it's actually like, it's truly an error. Yes, there are lots of frustration potentials. I'm very glad to hear that something is being done there.
Yes, we're trying to make this less and less a problem there. And that's why we have a special IDE plugin that basically allows us to make those manipulations and to make our compiler plugins work. And the one question that may be left here is the part where I'm again asking myself questions is, but there's kotlinx.serialization, right?
Yeah.
And it already works this way. And they didn't reinvent the wheel with it there. Well, the part with kotlinx.serialization, or for example, atomic foo things, is that those plugins live inside the Kotlin repository. And for example, you may probably notice then when you apply Gradle plugins in your project there, they also have always the same version as the Kotlin. Right, the plugin for serialization has the same version as the plugin for Kotlin.
Yep, exactly. You have two artifacts. You have like one runtime artifact that's kind of like the version of the like actual library, and then you have like the one that's just the same. Yeah.
Yes, the Gradle part.
The Gradle plugin,
and this Gradle plugin actually applies the serialization compiler plugin there, and they live inside the Kotlin repository. So anytime there are changes, they are also ported to the compiler that is bundled with IDE. So they are by default compatible, but well, we as a JetBrains product also could have gone the same way, right?
Yeah, I mean, I think even Compose, like the Compose compiler plugin, that it got like moved into the Kotlin repo specifically because it makes compatibility easier.
Yes, and they did it, and this is much nicer for them now to handle any compatibility issues. But they are all stable things, right? And the problem with being in the Kotlin repository for us is that we will be bundled to the release cycle of Kotlin. But we are experimental library. We are making changes every week. We need to be really fast in this. We need to have this ability to make really, really fast changes. That's why we invented this wheel that allowed us to have our own separate compiler plugin, not in the Kotlin repository, but which still works in IDE. And that's actually why it can also run with the older Kotlin versions and not just the current one, because we're also building for all of those versions and not just for IDE versions. So right now, if you go to our repositories, right now it's what, 2.1.10 Kotlin, right? So we have, I don't know, maybe around 15 or 20 different artifacts for compiler plugins, which are all built for different Kotlin versions. Like 6 of them stable Kotlin versions, 1 of them something like kRPC, and all others are a lot of different IDE forks of this compiler. Yes.
Oh my, that's it's a lot of work. But I mean, in turn, I mean, it also means that people can try it on whatever version of Kotlin they're on, and it also means that you can keep iterating like very quickly. Yes. Is a long-term goal still to move into the like Kotlin repository?
We didn't think about it yet. We will see what happens. Maybe earlier they will stabilize compiler plugin API. I don't know. We'll see. Yeah. I know that they have it in plans, but I don't know the priority or anything else. So right now we're sticking with it. It works pretty fine, and yeah.
I have more rabbit holes to go into, but do you have more questions that you want to ask yourself on the topic of compiler plugins? No,
I'm just really proud of this compiler plugin thing.
It is very, very cool. We mentioned kotlinx.serialization a couple of times. First for Protopuff. We mentioned kotlinx.serialization a couple of times. First for Protobuf and also just for compiler plugins. I'm just curious because obviously, like, when we're talking RPC, like in my head, there's still like the diagram with like an arrow, and then there's like maybe some JSON or some like binary hex format. Is there a relationship between kotlinx.serialization and kotlinx.rpc?
Frankly, yes, but we don't really want this relationship. We decided that it is a bit abusive. That's a joke, of course. For gRPC, no. So if you're talking about gRPC in protocol, there is no relationship to kotlinx serialization at all. If you're talking about kotlinx.rpc, we use serialization there basically to serialize messages.
Okay.
And we made it this way that you can use any format you want on the wire. So you can use JSON, you can use CBOR or protobuf just out of the box, or any other formats that implement serialization interfaces. I think they're called like binary format, string format interfaces. You implement them, you can use them in kotlinx.rpc.
Do I make my messages that go over the wire, do I annotate them as @serializable in kotlinx.rpc?
Yes. All of the messages that you use with kRPC should be annotated with serializable thing now. We didn't decide how we want to proceed with it yet. We will stay with this serialization scheme for now. But the reason why we started to doubt it is because some people said that maybe we don't want to have kotlinx serialization. And we don't have any exact plans for how to handle this right now, but maybe we will just have an abstraction layer like Ktor does. Ktor does it with plugins. Maybe it will be also plugin here, but we don't have a plugin system right now, so out of the question currently. But also maybe we will just make this serialization thing more abstract there, and it will be not just bundled to kotlinx serialization.
Okay.
Yes, but right now it is.
I don't think I have any more questions.
Okay.
Which is great. I think we've covered like a lot of ground here. I've learned that kotlinx.rpc is not just bound to one protocol. That we have kRPC and we have gRPC.
Yes.
But there's an entire multi-platform story actually attached to the gRPC story, which is very exciting. Something that really like puts my mind at ease, which is that in the gRPC situation, the proto files are actually the source of truth, and then that I'll get generated Kotlin interfaces from that I can just use, which makes the polyglot use case and crossing language boundaries just so much easier.
Yes.
And I guess also that, you know, RPC can happen on the same machine, that it can happen like across the network, that I should probably still write RPC services the same way that networked services in general are built, and that the same like caveats apply. Someone can just come with like a big, like comically big scissors and just cut the wire.
Yes.
And that might affect our service. But yeah, this is really cool. This seems like a really bright future for what's coming next.
Well, I hope so. Yes. Well, that's the project that me and my current team lead. We started as a hackathon project in JetBrains.
Really?
Yes, it was a hackathon project back in 2023, so like 1.5 years ago. And now it's my full-time job, and I'm really passionate about it. You know, I really want for it to be a very solid and popular library that solves people problems, that help them to build their thing easily and without any friction that they may have now.
Why did you decide to build it as a like a hackathon project? Because it doesn't seem like a trivial, like we'll just build this out in 48 hours and like we'll have something.
Yeah, that's true. Well, the initial, I always had this idea in mind that what I saw with my previous position looks really cool, and it would be cool to have as a library. And then I was told that we have already 3 to 4 solutions in JetBrains that I'm maintained and created separately, and some of them are just forks of the previous versions. And it's just so came in one like timeline, 1 month, that we had this idea, and then people who actually use those RPC services inside JetBrains said that, yeah, it would be cool to have a library, and we would use it. And we decided like, well, let's give it a try and see how it goes. And it still goes.
That's incredible. That's such a cool origin story. And again, like it turned into like an entirely kind of foundational technology, I would say. Still very fresh off the press. So I guess like all kinds of feedback is very much
yes
much wanted.
Yes, I'm trying to answer all of the questions on the GitHub and Slack. Sometimes I do it for 2, 3, or 4 weeks, but we are hearing everything. That's true, and we are taking all of the ideas from the community, all of the feedback, and we will use it for our design sessions, mostly for kRPC, but also for gRPC, of course. With gRPC, it is a little bit easier to understand what we need to do because it is an established technology, right? With kRPC, we're inventing something new, so we really need a lot of feedback there to understand what direction we want to go with.
Makes sense. So I guess let's get people to try it out, to play around with it in their little like toy projects and playgrounds. And then hopefully that's also going to help steer and kind of inform the direction in which kotlinx.rpc and kRPC might go in the future.
Yes.
Very cool. Alex, thank you so much
Thank you, Sebastian,
for coming here.
That was amazing.
Joining me in the Munich office, by the way. I don't think I said this in the beginning. Maybe I'll edit that in post. We'll see. Yeah, for this very special episode, very excited. We have long run out of our tea, so I think it's time for us to grab like some candy, maybe another cup, and relax for a little bit. I will have a very hard time like not like jumping straight onto my laptop and like starting to build something with kotlinx.rpc.
Yes,
very much so.
Thank you, Sebastian. It was a big pleasure to be here.
Lovely. Okay, thank you everybody who decided to tune in today, of course, as well, and we hope to see you in a future episode.